Looking at integration by recognition. This is something that it's done in some maths courses where you are integrating something you don't know how to integrate at first sight. It doesn't link back to techniques you've already learned, and it can be used sometimes to get out of that mess. Now, integration by recognition requires that you're given some information. Okay, yes, because in life some magic person's just gonna, when you're out in the real world, just gonna give you some information. But it's a worthwhile strategy, and it's a good way to demonstrate learning in calculus. But cynicism aside, I'm going to show you a fast way, and then I'm going to show you integration by recognition. The fast way only pertains to a course. Now, this is Australian, this video. It doesn't mean you people from overseas can't watch it. You're very welcome. Please subscribe. But basically, integration by recognition is something for a course which you can tell by the date. This is if you're looking at in the future, you're looking at me, and it's not 2020s, and the subjects are all called different names or from a different country. Sorry about that, but I'm making this primarily for my students at the moment, and I teach math methods and specialist maths. I teach both of them, and this is mainly to do with this subject, math methods. I will show you there's a more advanced, quicker method using a specialist maths technique just for interest, but that does not link to the subject math methods. Okay, just be aware of the difference. If you're doing math methods only and you are not doing specialist maths, you need to be using integration by recognition, especially when it's been asked for. So using this thing, which is in specialist maths only, it's called integration by substitution. And alright, so what we need to do is identify a function which we can call u. So we let u equal sine x. Now, why would I do that? Well, because you can rewrite the given function as this. Take the 3 out the front. Now, sine cubed x is sine x all cubed. So that would make the following. So if we make a substitution and we also find the derivative of this substitution, which we'll call du dx, if u equals sine x, the derivative of that with regards to x is cos x, and we could rearrange that as du equals cos x dx. Now hold that thought for a minute. Also, if we go back over here, once we've made that u substitution, u equals sine x, we can, going from this line here, we can say it's 3 times the integral of u cubed. Now, instead of writing cos x dx, we can just write du. Now we're integrating in regards to u, and it's a very simple one. So that would make u to the 4th times a quarter, or a quarter u to the power 4 plus constant. And then we unsubstitute back in terms of x, so we have 3/4 sine to the power 4x, or sine x all to the power 4 plus constant. Now let's see if we can get that using what the point of this video is, integration by recognition. So the given information might be worded like this or similarly. So see how in green it's given, some information is given to you, so you're given a function f of x to consider, and it's purely given to you a quarter, oops, I forgot my x there, a quarter sine x to the power 4. From that we have to find, now look closely, that says the derivative. We have to find the derivative of this f of x we're just given, and that will help us perform the above integration. Now, keen viewers would have spotted some similarities between the given function and when I did it with the specialist math technique, integration by substitution. After we did the u substitution back over here and we spat out a result, you'll see that this section here spits out that result. Okay, so interesting, right? Interesting. First thing then is we're going to find that f dash of x requested there. So the derivative of the given function, first thing I'm going to do is write that as sine x to the power 4, just to make it easy to follow, because we're going to use a chain rule. Now I need to make a u substitution here for the chain rule for differentiation, finding the derivative. So I just realized too that I haven't found the derivative yet. That dash shouldn't have been there. I've just jumped the gun with my symbology. Apologies for that. So first making a substitution there. F of u equals a quarter u to the power 4, where u is defined, or u of x in full, u is equal to sine x. This is the chain rule for differentiation, which is prior work. Thus the derivative of that, u dash of x, is cos x. Okay, cos x. So finding the derivative of the outer function, f dash of u, well, that would be the 4 gets multiplied on the front to the quarter, which makes 1. So I'm just going to write 1, invisible ink, alright, and then the power drops down by 1, so you actually get u cubed. And so the derivative is the chain rule with those two things multiplied together, so you'll have u cubed times cos x, which is sine cubed x cos x. Now remembering we had to find the integral of 3 times sine cubed x cos x dx. I'm writing it like that to make it a bit more explicit. You can see a clear match here between this function and this function here. So if we integrate this second row of pink, it should get back to what we had as the given information. Should get back to that. So if we integrate this, we're integrating the derivative, or finding the antiderivative of f dash of x, which will get us back to there. So that's 3 times a quarter sine, using this notation, sine x to the power 4, and we've got our constant on the end, and you can see we've got the same answers we saw over here. Looks like it's right. Okay, so disadvantages of this method. Well, if you're doing math methods only, you have to use it. You have to be able to use it. Okay, and you shan't show this on a math methods exam. But the disadvantage of the math methods integration by recognition is that you need information provided to you, and it is longer. But the advantage, I suppose, is that you don't need to learn this other technique here. Okay, so interesting. Pros and cons. Okay, so we got one last example here, and a little bit more involved, and we're just only going to do it by recognition, because we've kind of shown that integration by substitution is the hidden power behind this, but this is really just the math methods video. So recognition is what we're going to do. So we're given an f of x log 3x squared plus 1, and then we're asked to find f dash of x, and then use that information to find the integral of x over 3x squared plus 1 plus e to the 5x dx. Now we have to use a chain rule for differentiation on f of x to find f dash of x there, and I've written that down in function notation. So we need to identify f of u, so we make the u substitution. So f of u would be log of u, where the u substitution, u of x, would be what's inside the brackets there, 3x squared plus 1. While I'm over there, I'll just go u dash of x, and that's 6x. While I'm over here, I'll write that as 1 on u. Applying the chain rule now, and we have 1 on u times 6x. Substituting back in terms of x, unsubstituting, that would give us 6x over the top of 3x squared plus 1. Alright, now just the orange step is more of a thinking step, a reasoning step. So if we were to get this result we just found here, and we reverse that calculus using antiderivative integration, we would go back to what we originally had, which was, so if that's f dash of x, we would go back to f of x, which is given up here, log 3x squared plus 1. Okay, and you can see I've written that down the bottom in orange. And more to the point, if we had the integral of x over 3x squared plus 1, it would be 1/6 of the previous result. Go back to the at least one part of the requested integral. It was that there, so we actually had to integrate that which is sitting down there, and we've got a result for that part. Now we've got a sum here, so we can split it into two separate integrals, or two separate integrands, things being integrated. So let's do that, and then we should have our answer. Okay, so let's get this thing, let's take it home now. So on the homeward stretch, this is what I'm saying. Okay. Now this video assumes a whole bunch of previous knowledge that we can split the integral, and we know how to find the integral of e to the ax and all that. That's covered in previous videos. We've worked on that together. Now this first term, we've got a result there. So we have that. And we know the second term would be 1/5 e to the 5x plus constant. Done.